Hello, today I will start the review of the fabrication process. First, before to start the review, you have to know that the uh, mechanism of the its code name of the scaling down. Um, when 20th century, there is a very big scale of device like 118 nanometer to 113 nanometer, blah blah. But this means uh, uh, not real feature size on nowadays. It is only act like a code name, like for example, like Galaxy Note 10 or 11. But however, there is some rule on the code name. The uh, in order to boot slow, we have the area device area should be reduced by 0.5. So the area should be half size, then the feature size should scaled down by approximately 0.7. So when we cross the 0.7, then first one is 14 nanometer and second one is 10 nanometer, and then third one is 7 nanometer, and then nowadays uh, we make the 3 nanometer device on the Samsung or TSMC. Then why we should scaling down the device? Because there is four driving forces in the field. The first one, we should reduce the area, and then second one, we should increase the performance. This means when the channel resistance, if the resistivity is lowered, that means the its transistors delay time equal RC should be lowered. The delay time tau is lowered, then the frequency at frequency equal 1 over tau, so the frequency should be increased. This means the area should be lowered and performance should be upper. Third one, we should lower the power consumption. On the CMOS inverter, the power consumption equation is like the like this: P equals C VD square and F. We have to raise the performance, so the frequency F value should be upper, and then VD means the VD should normally the VD is fixed on the depend on its device characteristics, so it is normally fixed value. Then we only have to lower the capacitor of the its CMOS inverter. But you should know that the gate coupling should be raised, should be up. Then we should lower the other capacitor value, like a fin to fin capacitor or outer fringing capacitor or inner fringing capacitor. So we should lower the power consumption. Last, we should lower the cost because the business or company is only pursuing the its avenue, so the cost should be lowered. In old fashioned, we had to disconnect the device to device connection, so we use the low cost method to disconnect the device. Low cost is we give the silicon oxidation between the device, so we can physically disconnect the device. So however, it is very old-fashioned method because we have to scaling down, but the low cost consume very big space, so it is not a good idea. Okay, now we really start the fabrication process. First, we have to know the clean room. Clean room is the place that the semiconductor fabrication process is happening. Clean room is very important because if there is 10% defect for each mask, then after 7 lithography, there is 0.9, the 7 power of 0.9 equals only 0.48. This means we can only 48% of its complete device that yield. So the clean room's cleanness is very important. There is many units on the clean room, but ISO unit is also using, but it is not very popular. This means the maximum particles per 3 power of meter. There are many terminology of the fabrication process. There are FOB and FOSB and LAT and OHT. The FOB means front open unified part. This means the open in the front and we store the wafer on the unified part. FOSB is the same part and box, but we use on the different situations. FOSB is a shipping box, and we use only shipping situation. And then this is the similar but different terminology. LAT means wafer set, and it is normally used in device parts or using in science factory. And OHT is overhead hoist transport, and it is mechanic transporting system that works on the overhead. Next, the lithography. lithography process is these 5 steps, normally 5 steps. The first one, uh, we put photoresist on the substrate, and then we spinning the substrate. Then the photoresist is balanced and very shallow. Next, we expose the light on the photoresist. This process means exposure. However, by put on the mask and then defend the exposure of light selectively, then we can make the wannabe part of the photoresist. So we can defend the exposure selectively. Third one, the develop process is when we bake the photoresist, then it is enhanced or very weak, so we can selectively positive develop or negative develop. And then fourth, we can etch the its photoresist and substrate, and then we erase the rest of the photoresist, and this process is stripped. Photoresist is very important process. If there is misalignment between the device, then it makes very critical issue. So we use the alignment key to very well alignment, and then the alignment key example is like this. This is wafer, and the cross picture is example of alignment key. The first one picture is like this very big cross picture, and second one is a shallow cross picture. If the good alignment, the first one and second one combines where this is good case of the alignment. Next, finally, we have to know pellicle. It is the protective film to mask from the dust. If there is dust particle on the mask, that it makes the misalignment, so we protect the mask by pellicle, so it can make alignment well.